Good day, grade 12 learners. Welcome to today's mathematical literacy lesson. My name is Bernard Donko. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Today's lesson is about maps, plans, and other representations of the physical world. In other words, usually we call it maps and plans. And this topic will cost or count about 60 marks in your paper 2. So it is very important that you understand very well and try to apply yourself appropriately when it comes to answering the questions. Under maps and plans, today we want to look at part 1 of plans. What am I expecting you to understand here? At the end of the lesson, the hope is that you'll be able to identify the scale of a plan, define terms such as floor plan, elevation plan, layout plan, etc. And also be able to read values. That is, if you are given the dimensions on the plan, the length and the width. At the end of the lesson, I expect you to also be able to give the number of windows or doors, or no matter the kind of questions that you ask, you'll be able to use the plan that you are given to answer the questions. You should be able to measure the dimensions on the plan. You should be able to use plans in conjunction with other content, skills, or applications to complete a project. For example, you should be able to interpret plans to determine the dimensions of a room in order to establish the amount of carpet needed for the floor plan of the room. The other thing that we expect you to know is to be able to describe an item represented in a plan, be able to critique the design of a structure shown on a plan, be able to decide on an appropriate scale in which to draw a plan, and then draw the plan. You should be able to make connections between the plans showing different views of the same structure. For example, you should be able to explain which wall shown on the floor plan is represented on a particular side view plan. Now, because you're already in grade 12, we expect that your knowledge from grade 11 will come in handy here. Your knowledge about building plans, the skills about scales and maps in terms of the direction and point location should be very valuable for us here. So for now, I have given you some few questions that I would want you to attempt. Question 1, 2, and 3. And then I'm giving you about 8 minutes to answer this question. We'll come back and discuss them later. Let's look at the first question. You are given a map with the number scale of 1:60. You measure a length on the map to be 10 centimeters. What is this distance in real life? And I hope you managed to answer the questions. So here, for us to answer this question, remember, we need to fall on our knowledge of converting. So when you are not able to convert, then you are going to have a lot of challenges. Let's look at question 2. It says the distance on the map from Durban to Pietermaritzburg is 2.5 centimeters. Use the number scale of 1:3,120,000 to calculate the actual distance in kilometers. Again, you have to rely on your knowledge of converting to help you do that. And then the third question is, you are given the following bar scale. You measure the distance on the map to be 30 centimeters. What is the actual distance? So here, let us do the measure. I hope you took your ruler, and if you can see, I am not starting from the edge of the ruler, but I'm actually starting from where the 0 mark is. And I'm measuring the entire bar. And if you can look at my ruler, it takes me to 4.5 centimeters. 4.5 centimeters. So how do we use the information that we've gotten? What you then do is to say 4.5 centimeters that you measured is being used to represent 150 meters. Where am I getting the 150 meters from? It's from the bar. So the next thing that you should do is, you can see that the unit of meters and centimeters are not the same. So you first have to draw on your knowledge of converting and make sure the units are the same. So we are going to multiply the 150 meters by 100. Remember, in our previous slide, I showed you the conversion table. So to change from meters to centimeters, we are moving from a bigger unit to a smaller unit. Therefore, you multiply, and we multiply by 100. So that would take us to 4.5 centimeters represents 150, 2. That is 15,000 centimeters. Now that you are able to convert the two values to the same unit, then you divide both sides by the 4.5 centimeters. 4.5 centimeters. So you realize that the 4.5 divided by 4.5 will end up giving you 1. Then we now have 15,000 divided by 4.5 centimeters. So you quickly take your calculator, 15,000 divided by 4.5, and that should give you 3,333.33. So now you have gotten your scale. Then you go back to the question. The examiner was asking you to say, you have measured the distance on the map to be 30 centimeters. So basically, what we are expecting to know is that every time you measure one unit, I'm saying unit because, can you see that when we were cancelling, centimeters cancel centimeters, so there is no unit. So if you decide to measure in centimeters, then every 1 centimeter that you measure will give you 3,333.33 centimeters. So now that we have gotten 30, you write your 30 underneath the 30. Why? Because remember, you have gotten your scale now. The value on your left is the map value, and the value on your right is your actual or real value. So now the 30 centimeters is from the map. So the map value divided by the map value on the scale. Then we multiply by 3,333.33. And what will be your answer? Let us work together. So we have 30 multiplied by 3,333.33. And that should give you exactly 99,999.9. If you want to round it to a whole number, then that will be 100,000 centimeters. That is how we expect you to answer such questions in the examination. Let's move on. Remember, you have to measure the bar in order to get a scale. So how did I get the scale again? I measured from the beginning, from 0 to where the bar ends here. And that gave me 4.5. So you take your 4.5 in the unit that you measured. In this case, is centimeters. What are they representing in real life? They said it represents 150 meters in reality. That is your scale. Now, let's look at some of the terminologies that we use in maps and plans, especially in plans. We have 2D diagrams. Why are we learning this? Because we expect you to know most of these things we will be asking you in the examination. This you should be able to explain or define 2 or 3 of the terminologies, because each one that you're able to explain or define will give you 2 marks. So let's look at the first one. We have your 2D diagram. What is it? It's a diagram or picture having length and width only. Basically, it has got only 2 parts. Then we have our 3D. So what would be the difference between a 2D and a 3D? Clearly, you can see that the 3D is made up of real life. If we want to talk about that in terms of an object, it means it has the length, the width, and the height. Then we have bar scales. Bar scales are usually presented in the form of a picture. Remember our previous slide? We saw what we call a bar scale. Then we have what we call elevation plans. We have floor plans, number scale, and the scale. So what I am saying here is that in examination, we can ask you to explain or define any of these terminologies. Whenever you do not understand, feel free to ask the teacher so that they can explain a little bit further. So let's look at the scale. It determines how many times smaller an object shown on a plan or map is than its actual size. Now, let's look at the types of plans that we have. We have our floor plan or layout plans. We have elevation plans, and we'll tackle that in the next lesson. And then we have also got the design plans. Now, let's look at each one. When we talk of floor or layout plans, what do we mean by that? Floor layout plans is a simple line drawn showing the rooms as though you are looking at the object from above. And the purpose of this is to show the layout and design of the 3D structure. The floor plan for a house usually shows the layout of different rooms, the positions of windows and doors, as well as the position of fittings like cupboards, stoves, toilets, etc. Now, it is important to understand the layout of floor plans. In order to do this, you have to look at the keys that are given. Sometimes in certain exam papers, they don't say keys, they say legend. So whether you see legend or keys, we are referring to the same thing. This is an example of a floor plan. What do we see here? We have seen the island, we've seen breakfast table, we have the family room, we have utility closet. What other things can you see from this diagram? Good. When you see this quarter sign, that is the sign for a door, correct? Now, we can also look at the floor plan and we will see doors. You see what I was referring to here? This is another one, but this time it is showing 2 of the quarters, and that is a double door. So we expect you to be able to know and be able to identify these symbols. Take note, when working with a scale on floor plans, in order to be able to calculate the dimensions of an object on a scale or map, you must be able to work with the scale. The knowledge on number and bar scales needed to be drawn upon in this section is very vital for proper understanding. So let's look at what I am showing you now. On your left is what we call the bar scale. Remember, during our baseline, I was explaining to you how to use the bar scale. And then on your right side here is what we have as our number scale. So whenever you see a bar scale, remember you have to be able to change or convert the bar scale into a number scale. And how do we do that again? You guessed that. You have to measure the entire bar. Measure it. Take your ruler and that bar scale which is given to you on the question paper, measure it. So for example, let's say you are given this bar scale in an examination. How do you work with it? You measure the entire length of the bar. Can we put example? Let's say it is 4.2 centimeters. How do you use it? So your first step is to write that value which you have measured into some form of number scale. So it will be 4.2 centimeters. Then you put 2 dots, which you call the column. And then on your right side, you write the last value on your bar. Why? Because you measured the whole bar. So here will be 3. Remember, they have given you the unit. Here is our unit. It is kilometers. So you write here kilometers. I do hope you understand now how to use the bar scale. So now, can you see you have managed to write the bar scale in the form of a number scale? But if you look carefully, on your left, the unit is centimeters. On your right, the unit is kilometers. Here is the key. The value on your left here is what you call the map measurement or the map measure. And then the value on your right is what you call the real or actual measurement. Don't forget that. So whenever we are talking about the bar scale, we are saying, like this example, we are saying that 4.2 centimeters on the map represents 3 kilometers in reality. Let's go to the next one. You see here, we have in the simplest form, on my left, it is 1:20,000. In examination, we will be asking you, we can ask you to explain what is 1:20,000. What we want you to write in the examination is this information here. I hope you can see it. It says, it means that 1 unit on the map represents 25, is 20,000. 20,000 units on the ground or in reality. We want you to write it in the form of words, and that alone will give you 2 marks. So you realize that you are going to pass, you'll be fine as long as you do the basics right. The value on your right here, that 20,000 is what we call scale factor. What is a scale factor? It is that value which determines how big the real object will be. So look at this diagram that I'm showing you here on the screen. Whenever you get your question paper, draw that diagram. It will help you a lot. So let's say the examiner wants you to find the actual distance. You see this line here, the line which is vertical, it says multiply, meaning if you want to find the actual distance, multiply the value that you measured or the one that has been given to you in the question by the scale factor. Remember again, I was telling you that the scale factor is your value on the right of the scale, as long as the one on the left is 1. So let's get back. The value or the line that is seen here is the divide. It is the divide. So how do we apply that? Assuming they ask you to find the measured distance, it means it is going to be actual distance divided by the scale factor. Let's move on. You have to be able to determine the scale of a map. You have to be able to measure the distance on the map. But now let's go further so that we can put it into practical terms. Look at these ones. Mention 2 types of scale used in drawings. And I'm giving you a minute to remember. Remember, we spoke about them, that there are different types of scales. Which ones are they? Good. Bar scale and number scale. Let's look at number 2. If using the scale of 1 state what each of the following on the plan equal to in actual length. So we look at 2.1. What's our length? It is 1 millimeter on the plan. What would that be in reality? We are going to find the answers very soon. So can you quickly go through question 1 to question 4 and see how best you can work? I'm giving you 5 minutes to do that. Welcome back. Now, let's look at how you were supposed to answer this. So, we're expecting you to mention the 2 types of scales that we have talked about so far, which is bar scale and number scale. How were you supposed to do question 2.1? You take the value that you have been given, you multiply it by 30. What is the 30 again? What is the name we give to? Good. That's what you call the scale factor. It is the value that's going to tell you how big the real object will be. So you can see 1 by 30 will give me 30 millimeters. And if I want to change it to centimeters, then all I do is to divide it by 10. But here we wanted the value only to be in millimeters. So there was no point in terms of having to convert again. Let's look at the next one. You were given 3 centimeters on the plan. So what will be the real value? It will become 3 times 30. That will give you 90 centimeters. Explain the meaning of the scale 1:30. So in examination, we expect you to write this sentence. Write it so that we give you 2 marks free. So you say it means that 1 unit on the plan represents 30 units in reality, and that will give you 2 marks. Again, remember I've spoken to you about scale factor. So look at these 2, 1:6. Which of the value is the scale factor? The one on your right side, which is the 6. And the 4.2, the scale factor is our 4. I hope this has helped a lot. Now, let's look at exam type questions. So we have been given exam type questions. We want to answer them. The first one, it says study the diagram alongside and answer the questions that follow. So you have got 5 minutes. I want you to attempt them. Do not worry about making mistakes. We will discuss the solutions together. So you have got 5 minutes to answer these questions quickly so that we come back and give our solutions. Welcome back. So our question 1.1, we are supposed to look at the plan that has been given to us. What kind of plan is this? Good. That is a floor plan. So it says, what kind of room is this one? For 2 marks. What kind of room is it? Good. That is a bachelor room. Or you can say it is a 1-bedroom. So in this point, you just say it's a bachelor or a 1-bedroom. And that will be enough for us to give you 2 marks. How about the second one, 1.2? How many doors does the room have? Good. We have 1 here, and there is another one. So how many doors? We have got 2. And then the last one here says, how many windows does the room have? In our case, we have got only 1 window. And so far, if you were able to answer these questions, that would give you already 6 marks. Let's look at the next point. With the same plan, now I'm asking you, is there an alternative position for the bed if the bed may not be in front of a window? Where do you think we're supposed to put this bed? Now, that is up to you, but I was hoping you can say we can move the TV away and bring the bed here. So we can actually move the bed to our right so that it doesn't have to be next to the window. And then you must explain why. Because remember, we are saying that we don't want the bed to be next to the window. We don't want somebody jumping in at night and causing troubles for us. Let's look at 1.5. Which items would need to be removed from the room if the single bed was exchanged for a double bed? What can you remove from this room here? And this is the side table and the TV with the TV stand. So basically, we can remove those items so that we have space for the double bed. Remember the closet, we can't remove it. It's already built in. And then the bath is already also built in, so we can't change anything. Now, here we're coming to work on exam type of questions. These are the measurements for the actual size of a building, and we are expected to get the plan measurement. Let's go through the question quickly. It says an architect is drawing a plan of a building in the scale 1:20. Please remember, highlight the scale that you have been given because you would need it. The table below shows the actual or the real world measurements of some of the dimensions of the building. You need to use the scale to determine how long the architect will need to draw these dimensions on the plan. So here I have done the first one for you. Look at it carefully. This is the 8, which is the real. Remember, I gave you the diagram. So you must also draw that on your paper. Here is your AD, here is your MD, and here is your SF. AD, actual dimensions or actual measurement. The MD is your map measurement, the one that you measure from the map, and your scale factor is the value that is on your right here. I hope you can see it, that value. So let's see. What did I do here? I took the 8, but look at the question. It says we must find the measure on the plan. So we are looking for MD. So it means if we look at MD, when we cover it, we are going to be having AD divided by SF. So my AD is my 8, my SF, which is my scale factor, remember I got it from the scale, 20. Why am I multiplying by 100? I'm multiplying by 100 because I am changing it from meters to centimeters. Remember, the examiner says we must change all the values from meters to centimeters. So we say 8, which is the actual, divided by the SF, which is a scale factor of 20. We times everything by 100, and that will give us 40 centimeters. So it is your turn now. I want you to find the values for these spaces. I'm giving you 8 minutes. Can we quickly work on that and get the answers? Welcome back. So what was supposed to have been here? This portion was supposed to be 4.5 meters divided by 20, multiply everything by 100. What is your answer? 4.5 divided by 20 multiplied by 100, and that should give you the plan measurement of 22.5 centimeters. Remember, we are dividing by 100 because we want to change or convert from meters to centimeters. How about the next one? You take it 2.2 meters divided by 20, multiply everything by 100. That will give you 2.2 divided by 20, multiplied by 100, and your answer should be 11 centimeters. And then what did you get for the roof height? Again, you do the same thing. 1.2 meters divided by 20, close bracket, multiplied by 100. So you have 1.2 divided by 20, multiplied by 100, and you're going to get 6 centimeters. I hope you got all these things correct. Well done. You are doing great. Let's go to the door height. So now we have 1.8 meters divided by 20, close the bracket, multiply by 100. So you go and press that 1.8, you divide that by 20, you multiply everything by 100, and that should give you 9. So you have your 9 centimeters. Well done if you managed to get these values correct. Let's go to question 3. This time we have been given a plan for a laboratory. And the questions are saying, study the diagram alongside and answer the questions that follow. So our first question is, which item is located at the far corner of the laboratory as a person enters the laboratory? So where does the person enter? Here is our point. There is our entrance. So once you enter, which item is at the far corner? So we are expecting that you are able to identify this area. And what is the name? The radioactive waste section. How about 3.2? I want you to try 3.2. I'm giving you 2 minutes to do that. Let's go. Welcome back. So 3.2 says, calculate the width of the laboratory if the total floor area, highlight it as you go along, highlight all the keywords that you are being given. If the total floor area is 18.9 square meters, 18.9 square meters, use the following formula. So you see here, the examiner gave us the formula. It says to find the width, you must divide the total area. What's our total area again? Good, very good. 18.9 meters squared. They said we must divide that by the length. Where are we going to get the length? You go to the diagram. Look, there it is. What is the value? 4.5 meters. So being able to substitute these values already give you marks. So go back to your calculator and press your 18.9. Don't press the meter squared. It's not part of what you should press. Those are units. You must only press the numbers. So you press the 18.9 and then you divide it by 4.5. Again, don't press the units. It's not part. So what did you get? Good. You got 4.2 meters. If you got that correct, you have done very well. Thank you very much. Let's go to our next question. I want you to attempt this one, and I'm giving you 3 minutes to do that. Welcome back. The question says, the scale used on the layout plan is 1:58. Calculate the actual length. So remember, here is our key point, actual, A. Remember I told you, draw your diagram. This line means divide, and then this line means multiply. So here is your actual distance. This side is your MD, or your measured distance, and here is your SF. Where do you get your SF? Good, you get it from the scale. Look, there is your SF. So what's our SF? 58. The scale factor is 58. Calculate the actual length of the table on the layout plan. If it is scale length is 2.26 centimeters. So here, can you see it's 2.26 centimeters? That is the MD. What's our MD? It's our measured distance. They have already measured for us. So if you can check in this triangle, they have given us 2 of the values already. What do we have? We have our SF, and then we have our MD. So when you have SF and you have MD, what do? Good, we multiply them together. So we are going to take 58 and we multiply that by 2.26 centimeters. Don't say, or don't do this. Don't say 1:58 multiplied by 2.26. No. You can't do that. When you do that, you don't get any mark. We are going to give a 0 in the exam. So we don't multiply everything by the whole scale. We only multiply by the scale factor. So what did you get? Take your calculator, press 58, multiply by 2.26. Again, you don't press the centimeters. It's not part of what you should press. So you're going to get 131.08. Then you write it down. 131.08. If the examiner says round it to a whole number, then you are going to get 131. If they didn't say that, you leave it like that, you're going to get your marks. So remember, being able to multiply the 58 by the 2.2 might even be able to give you 2 marks, and your answer also give you 2 marks. Another mark that will give you 3 for this step. So you are going to do very well as long as you do the basics right. Now, let's look at the next portion.